All right, we will go ahead and record for today. Couple of quick announcements for you. Your quiz is due today at 5 o'clock. If you haven't taken it already. Let me see if there's anything else. I have not graded your Gestalt art yet, so I will have that graded for you later. I want to check on the syllabus and see if there's anything we need to know. I did put up your study guide for the first exam. We are going to have a review session the night before. And additionally, if you need the testing center for any sort of accommodations, get that form to me by Wednesday afternoon. We will not have class on Wednesday, but I will be back in my office around 3 o'clock. So if you need to get those forms to me, I need them a week ahead of time. So you need to get that to me so I can sign it. You're also going to need to get that to Heather English about a week ahead of time. Okay. All right. So I want to check a couple of things just to make sure. Quiz 3 will post on September 19th. Actually, we will do our review session on Sunday. I, for some reason, kept thinking our exam was on Wednesday because the Gen Psych classes was, but it's going to be on Monday. I'm sorry. But the study guide was up on Friday, so I'm already a week ahead. So get that form to me today. I will be in my office around 3:30 to 5 if you need to get those accommodations in. If you need the testing center, get it to me, okay? And we are basically going to cover visual perception 1 and 2. So the exam will cover the history of cognitive psych, some brain questions, and then largely visual perception. And we will finish that up this week for sure. That's a promise. Yeah. Did I not put it up?
I'm asking, is it up now or?
I think it should be. Can y'all check? Because I'm pretty sure I put it up, but sometimes I'm known to forget. I looked at it at least.
Exam 1 study guide.
Okay, it is up.
Lecture notes and course documents.
Okay. All right. Thank goodness. Sorry, I think I've been a little scattered this weekend. I have a lot on my plate this week.
I just want to make sure that I have that right.
Yeah, the study guide is up and we will do a review session on Sunday night. Does anybody have a particular time that they would like that session to be? We're going to have it in the student lounge. Anything before 7? That's actually perfect. You want to do it at 6? Because then I do study sessions for the research method students. So we'll go ahead and do that in the student lounge at 6 o'clock. I'm actually really glad I didn't schedule your exams on the same day because that would have been back-to-back sessions, which is a lot for me. So I know it's a little sooner than we thought, but we're going to manage to get everything covered before then. I would also say keep up with your readings in McRaney. A couple of our short answer questions specifically have to do with some of the McRaney readings. So make sure that you get those in. All right. So we are still talking about visual perception, but I can promise you we will be on to number 2 by next time for sure when I record. Remember, no class on Wednesday. I will be posting the video for you later this evening. It will be on YouTube, and just make sure that you get that watched by Friday because we're going to pick up right where that recording leaves off. So the last time that we were here, we were talking about some of the different rules that we use when we're recognizing objects to separate an object from its background. And the Gestaltists have different types of grouping rules. These are sets of rules that describe when elements in an image group together. So we're going to look at a few different examples of each of these. So don't feel like you have to write all of these down right now because we're going to go through a lot of different picture examples so that you get an idea of what each of these are. Okay. So we're going to talk about good continuation. It's sometimes referred to as continuity. This is basically the idea that items group together if they are on the same contour. We have texture segmentation, so basically dividing boundaries of objects by texture. We have the rule of similarity, the rule of proximity, and the rule of closure. Well, I'm glad I put it up early. If I thought the exam was on Wednesday and I put it up on Wednesday, you would have only had 5 days, which is still not nothing. Like, I recognize I don't have to give you a study guide, but I like to. Yes, I'm aware. Oh, I don't need your thanks. I think it makes your life easier. And for those of you that haven't had me for a class before, I generally don't try to trick you with these. If it's on the study guide, it will be on the test. And if it turns out there's something I neglected that was in the test, but not on the study guide, we'll talk about it when we're taking the exam and I'll help you out. Okay? Fair's fair. Okay, so this is texture segmentation. This is where we kind of left off. Dharma, you're looking a little confused. Are you having trouble seeing the boundary? One thing that's nice about doing this on Zoom is we've got annotate.
Right, like I can see the groupings, but I just didn't like it because it was different.
See, I'm helping. Look, I'm helping. Look what I made. So you can kind of see the boundaries of the texture differences here. I'm going to go ahead and clear this, but I am going to trace it with the cursor. So you can kind of see this one's a little harder to parse because there is a lot of similarity in this top portion between texture, but this one hopefully is a bit easier to notice. Additionally, we see that there's a boundary here because the texture changes. So this would be a good example of texture segmentation. Okay. This is the rule of similarity. So instead of thinking of these as kind of a row of asterisks and a row of octagons, we tend to think of it kind of as a square of asterisks and a square of octagons, because we're going by the law of pragnance here. We're trying to perceive the simplest possible structure. Here's the law of closure. So again, this is definitely where we left off because I remember talking about Pac-Man. So you can kind of see there are a few different ways to interpret this figure. You can think of it as 5 different Pac-Men and a bunch of broken lines, but I don't know about you, but what I am seeing is an arrow. So here's my question. If the arrow is there, are these Pac-Men or what are they to your perception? They'd be circles, right? They're just being blocked by the arrow. Now, we don't actually know if there are circles underneath there. In fact, the way that this is presented, there aren't circles, but because of the way that this image is constructed, it looks like these are circles, but the big white arrow is kind of overlapping them. So this is the law of closure. We're actually closing off negative space to make a boundary. Here is the law of proximity. So can anybody tell me what they see here? Like 2 sets of windows? And are you more likely to group these 2 together or these 2 together? The ones that are closer to each other, we're going to be more likely to group together. This extra distance right here creates a boundary. Kind of cool, huh? And I hope you had fun making art. I will try to grade it this afternoon, or I will grade it tomorrow morning. I have like 2 hours before my faculty meeting. And hopefully, if I'm still alive on Friday, because I will be leading that faculty meeting, hopefully I will still be alive and able to teach class on Friday. That's debatable, but we'll see. Okay. Here is the law of similarity. So hopefully you're kind of seeing what I'm seeing here. We've got a cross and then circles kind of in the background, and we're grouping those together on the basis of similar shape. I do that a lot. Yeah, after that 5K, I had sinus problems all afternoon because I had a sneezing fit right before we started. My sinuses just did not like that front coming through. Oh, from the stickers? Yeah. I ran into a patch of stickers. Ashton got to watch me pull them out and actually bury one even deeper into my finger. And I screamed a lot. No, I'm talking about the stickers that catch onto your socks when you go running in weeds. They were big and they hurt. Okay, This is the law of good continuation, and I'm going to use annotate to kind of illustrate what good continuation is here. So when we're kind of looking at this, we tend to perceive lines as going on smoothly in the distance. We don't normally expect sudden changes. So if I've got a line that's kind of following this direction, I'm not suddenly going to have a weird turn and have it go this way. I'm going to have that line continue. So we get that perception of two wavy lines, AOD and COB, intersecting each other. Do you kind of get that perception? You don't perceive it as something like this, like there's this one intersecting with this one. Nobody perceives it that way. That's not how that works. We tend to have those smooth interconnected lines. Yes, Sarah.
What if you understand it as four separate lines tied together in a bond?
We can have individual differences in perception. We're talking about what the majority of people see, because it does get more complicated when these principles start to conflict with each other. Okay. So here's another example of the law of closure. Does anybody know what this is the logo for? That is not Panda Express. Yep, it's the World Wildlife Foundation. Would you like to see the Panda Express logo?
Yes.
Okay. Pittsburgh, Kansas is getting a Panda Express. They're very excited. I also heard that they're adding Beyond Orange Chicken. So like fake orange chicken. I would eat it. Okay, so it's pretty close, but there's definitely closure in there's not a Gestalt principle of closure, although there is right here. There is right here, but yeah, it's a slightly different logo. This is for the World Wildlife Fund or the World Wildlife Federation. It's the reason that World Wrestling Entertainment is called WWE. It used to be called WWF, but they sued. The World Wildlife Federation sued and won, so now they're called the WWE. Okay. So this is what I was kind of getting at. What happens when these laws conflict with each other? So somebody take a look, everybody take a look at row A. So we could group on the basis of proximity here, or we could group on the basis of shape similarity. So let's go ahead and take a poll. Who's grouping A on the basis of proximity? Okay. Who's grouping on the basis of shape similarity? Who is not grouping that at all and you're just doing what you feel like? That is okay too. Okay, so this one has pretty clear. Most people, when they are polled, tend to default to proximity for A. Now, B is where it gets more complicated. We have these shapes which are not filled in and these shapes which are colored in. So are you going to group on the basis of color similarity or proximity? Who picks proximity? Who picks color? And really, this one's not that hard because we can group proximity and color similarity are kind of working together here. But what about C? C is a lot more complicated now. Is it proximity? Is it color similarity? Which one are you grouping on the basis of here? Who's grouping on the basis of color similarity? Who's grouping on proximity? Yeah, me too. Who has no idea what they're grouping with, but they'll try their best? That is okay. And shape is fine too. Everybody is going to be different here. So Quinlan and Wilton actually found back in 1998 that when we have these kind of situations, proximity is the one that we tend to rely on the most. But if there's a mismatch, we're going to focus more on either color similarity or shape similarity. I do like to occasionally cite my sources. Okay, everybody good? Aaliyah, do you need a little more time? Okay, So now that we've kind of used these grouping principles to figure out the edges of objects, we can move into figure ground segregation. So to be able to recognize or perceive an object, also known as the figure, you need to be able to separate it from its background, which is also referred to as the ground. So here's what's kind of interesting. Whatever is functioning as the figure will have a shape. So it has form, it has contours or edges, and it tends to exist in the front of the ground. On the other hand, the ground will be formless. It will not have a shape. So what's interesting is that this is something that you and I do so well that if we want to study it, we need to work with very special stimuli. In this particular case, we're going to look at reversible figure ground images and actually see your perception shift back and forth between the figure and the ground. So when I say it's reversible, that means that depending on your perception, what was the ground will suddenly turn into the figure and back and forth. This is the white peach ginger bubbly. It says sophisticated. Bad puns, we love them. Well, maybe you don't, but I do. And it also says heya on the lid. It's kind of weird. Well, I had some water. You know what that means. Oh, you know it. All right. Everybody good? Okay. So here's kind of an example. Many of you have seen this before. The face and the vase, or the faces and the candlestick. So this is a case where you actually have a reversible figure and a ground. So you can have this orange vase or candlestick against a white formless background. But if you focus on the parts of the face, suddenly it becomes two white faces against an orange background. So your perception is constantly shifting back and forth between an orange background to an orange vase, or white faces to a white background. So you're constantly shifting your perception back and forth and back and forth. You cannot see them both simultaneously. They are rapidly shifting back and forth with each other. It's kind of like that one where it's either a rabbit or a duck. I like to call it a dunny. It's a duck bunny, a dunny. Same sort of thing. You can't perceive the rabbit or the duck at the same time. You are constantly going to be shifting your perception between the two. Okay, so now that we've separated an object from its background using the Gestalt principles to figure out where contours are, the next thing that we can do is detect object features. This is going to require the use of color perception and depth perception. So this is the part of class that you will like, because we're going to talk about color illusions and depth illusions. So we're going to start by talking about color vision, which frankly, folks, is one of my favorite things about being able to see. I love seeing colors. So let's just kind of get a poll. Whose favorite color is red? Whose favorite color is blue? Whose favorite color is green? Whose favorite color is yellow? Yeah, nobody ever picks yellow. Whose favorite color is pink? Whose favorite color is orange? Whose favorite color is purple? Is there a color I did not name that is your favorite color? Black? Okay.
White.
White? Anybody like brown? My lab mate was a very big fan of brown. You like all the colors?
Different. I just feel like if I like one, the colors will feel sad.
Well, so, you know, a very easy way to pick it. That's why you pick white. White technically has all of the other wavelengths of all other colors. So it, huh?
So does black.
No, black is the absence. Black is the absence of all of those. So Well, we're talking about light, but I'm also kind of referring to pigment, and pigment is where it gets really tricky. Okay, so let's talk about the importance of color vision. So color vision helps you separate objects from their background, and they also help you with object recognition. If I told you to go find an apple somewhere, one of the reasons you would have a pretty easy time finding an apple is that really apples only come in a small set of colors, and that aids in your recognition. Additionally, in the animal kingdom, certain types of colors are often signs that you should avoid something. So like if you are in the Amazonian jungles, bright colors are generally your sign to stay away from things because those things will probably be pretty poisonous. Now, when we talk about color, it turns out that there are three major aspects of color. We have hue, we have brightness, and we have saturation. So the hue is actually the color itself. It's my mouth just does not want to work today. Hue is basically what separates red from blue. So it's the actual color. Brightness is the perceived intensity of that light. So a color that is very, very intensely blue. So for example, Emanuela has a pretty blue shirt, and Sarah does, and also Aaliyah does. Those are very, very bright blues. They're very, very intense, and they also don't have a lot of saturation. Saturation is when we start to add other colors like white or gray so that things become a bit more muted. So for example, this blue in my St. Louis Blues jersey is a pretty bright blue. It's very intense, but it's not saturated. Can anybody find some clothing colors here that you're wearing that might be a little bit saturated? Well, that's more of a brightness issue. Sada, your sweatshirt is actually a pretty muted blue. Like it's not a pure blue. It's a blue that looks like it has a little bit of gray mixed in, so it's kind of dusky. Nicole, your green shirt is a little bit muted. It has some saturation in it. Yeah. Your denim could be saturated. Yeah, exactly. So this is where I get kind of dorky. Is anybody here really into color analysis? Like you're a fall, you're an autumn, you're a winter. Huh?
I know somebody.
So that's how I understand saturation pretty well. Like I am an autumn, and I don't always need to be wearing bright colors. Like certain bright colors do not look good on me, and black makes me look like I'm dead. Like if it's too close to my face, I just look washed out. So those are some different aspects of color: hue, brightness, and saturation. So how do we see color? And I kind of brought this up last week. You have three different types of cones in your retina. Bless you. Sorry, you had kind of a cycle. So I was like, I was going to wait until it was all done, because saying bless you after every one, like I am a chronic sneezer and I feel so bad when everybody's just like, bless you, bless you, bless you. So we have three different types of cone receptors in our retina. So we have cones that are responsive to short wavelengths, which means that they are maximally sensitive to blue or purple. We have cones that are sensitive to medium wavelengths, which corresponds to the color green or yellow. And then we have red cones, or cones that respond best to long wavelengths. They're going to respond best to red. Now, one of the things that you might find kind of interesting is that I occasionally will call these blue, green, and red cones, but really notice that they respond to a distribution of wavelengths. So cones that we call quote unquote blue also respond to green. Cones that are green respond to blue, and they respond to yellow, and sometimes they respond to red. Red responds to certain shades of blue, green, and yellow, but we call them red cones. So we're talking about where their peak sensitivity is, but do be aware that your cones can be activated by a variety of different colors. Now, I've only mentioned blue, green, and red wavelengths of light. When you mix all of those together and you maximally activate all three types of cones, you get white light. So how many of you did this when you were a kid? And it's okay if you didn't do this. How many of you would get up really close to your computer monitor like I'm doing right now, and you looked at white and you could see the red, green, and blue pixels that made up the white light on your monitor? Well, first of all, don't do that. It's bad for your eyes. And given that many of you are wearing glasses, it is probably too late for you. Me too. But that white light is all three of those cones maximally activated, but it's the relative stimulation of each type of cone that allows us to see all the different colors that there are. Now, remember, if you only have two cones that work, you're going to get into some type of color blindness. If you have only one type of cone, you're not going to see color at all. So having these three types of cones allows us to see any color that exists. Ashton, you look like you have a question. You're thinking about it. Then you're what's called a rod monochromat. You still won't see color. And you also won't have good visual detail because the cones are all about those fine details. Yes, we did talk about it, but hey, there is no shame in getting a refresher. It is okay. Okay, so here's the thing about trichromacy. So those three cones enabling you to see every possible color. It doesn't account for things like negative after images. So we're going to do a demonstration. I'm going to pause this really quick. And I'm going to pause recording because I don't want to get into trouble with copyright. But I can do something else. So I'm going to resume share. Okay. Chrome. This is something I do in Gen Psych, and people really seem to like it. Where's the vid? Okay, this is called disappearing fluff. Okay, so I'll try to make it a little bit bigger if I can. There. Okay, so the idea is that as you stare at that dot, that fluff is going to start disappearing from your view if you try not to blink. You remember it now? Okay, do you want to know how the fluff works? So the idea here is that your brain is storing the after image of that, and it's canceling out what's in your short-term memory in that case. So we end up with the sensation of gray. Oh, this one's great. You got to see this. This is another one that kind of messes with after images. So if you watch this, eventually it'll look like the dot will disappear, or the dots will disappear. Here we go. The more you watch it, the more it'll look like the dots become erased. Play. Here we go. So at some point you'll see one of the dots turn green, and then it'll start erasing all of the other dots because of the way that your after images work. Isn't that weird? I love color illusions. Okay, so those are just a few different examples of negative after images. And the problem is that trichromacy doesn't really tell us anything about that. And so we have what is referred to as opponent process theory. And basically what opponent process theory says is that colors for us tend to be organized in three different pairs: red versus green, blue versus yellow, and black versus white. So here's what I kind of mean by negative after images and opponent process. Okay, has anybody ever seen an orangish yellow? How many of you have seen a bluish violet or a reddish violet? How many of you have seen a greenish red? Never. How about a reddish green? Not really. So one of the things that we find is that for us to be able to distinguish between different type of colors, we need three different comparisons. So we have red and green, So that's the medium wavelength cones versus the long wavelength cones. So you can't simultaneously see something being red and green at the same time. So if I stare at something red, it's going to produce a green after image. If I stare at something green, it's going to produce a red after image. Blue, so the short wavelength cones versus yellow, which are made up of the medium and the long wavelength cones. So just like I can't see a reddish green, I cannot see a bluish yellow or a yellowish blue. So if I look at something blue, it is going to produce a yellow after image. And then we have black and white, which is probably one of the easiest ones to see. And here's a case where I reveal a little bit too much about myself. When I was a kid, this is probably also why I need glasses. I like to stare at light bulbs because when you looked away and you looked at the wall, you could see the negative after image of them. And it was black because you'd be looking at a white light, you'd look over at the wall, it would produce something black in color. So black is none of the cones are activated, white is all three cones are activated. Right. Everybody good? Okay. So here's something kind of interesting. And for anybody who's watching this on recording, I'm apologizing really quick. I'm going to go turn out the lights. Okay. Did anybody's did anybody's shirt color change when I turned out the lights? No. So one of the questions that we occasionally get, your experience of color is based on the wavelengths of light that are reflected by an object. So you might be asking yourself, if my experience of a color is based on the light that is reflected, what happens when the lighting conditions change? Does that change my perception of a color? No. We actually have something called color constancy. So many of you will see this happen. So for those of you who don't know, I drive like a tiny little Ford hatchback, like a Ford Fiesta hatchback, and it's white. But before that, I had an electric blue PT Cruiser, and I loved that PT Cruiser. And it's a very noticeable bright blue. Some of you might have cars that are very bright in color. Like somebody has a really nice bright yellow car that I really, really like in the student parking lot. I want to know who has that yellow car because it's awesome. But I want you to imagine that you have a brightly colored car, and in a couple of months, it's going to start getting dark right at 5 o'clock. We're not going to be very happy with that, but we will learn to live with it. But let's say you drop your car off and it's daytime, and you go back to the parking lot after 5 and it's dark, and you don't go, oh my gosh, somebody took my car, replaced it with this car that is not quite the same color. No, we don't do that. We know that that's still our same car and that it's still the same color, even when the lighting conditions change. We know this. When I turn out the lights, you don't go, oh my gosh, my clothes changed color. Nobody does that because of color constancy. And what this tells us is that color does not just depend on the wavelengths reflected from the object. Your brain takes into account the fact that conditions change. And this is what is known as Retinex theory. In bright lighting conditions, you have a certain ratio of red, green, and blue cones that are firing for a particular color. That ratio will be the same regardless of whether the lighting changes. Yes?
What about black light? Where like your white shirt can become like a tinted blue, or like your shorts become like a different version of pink?
Well, and that's because you're adding a filter to that light, and you're changing the way that the light appears and the way that light's reflected off of the object. It's like when you're in theater and you add a gel filter. That's basically what you've done. It's fun ways to mess with your perception. So here's something that's kind of interesting. When you mix blue and yellow with crayons, what color do you get? If you take a light and you pass light through a blue filter and a yellow filter, you don't get green, you get white. Because light and pigment are very, very different things. Okay, so in general, yeah, I'm sorry. You know how I get so excited talking about stuff. I'm sorry.
Even longer whenever I'm trying to like listen, take notes on like different things. I'm like, what word am I writing right now?
Oh no, that's okay. That's multitasking. And we're all bad at multitasking. Every single one of us. We all think we can do it, but we can't. And don't worry, we'll talk about that more after the first exam. We're going to talk about attention. It's going to be great. So whatever I record for you, it'll probably be about a half an hour. And the great part is it's a YouTube video. You can slow me down. You can speed me up. I tend to find I'm best to listen to at 1.25 times, but that's just me. And yes, I do watch my own videos sometimes. I like hearing how I deliver content and seeing what I could do better. But you can pause me. If I'm going too quickly, you can always rewind me. We good now?
Is there one?
Do you need captions?
I'll just ask you.
I didn't do transcription for that one, so probably not, but the auto generate ought to be okay. But let me know if there's anything you want clarification on, because captions take a lot of time.
Right.
Yeah. Sorry. Okay. So we don't usually see colors in isolation. Like right now, I'm looking at colors that are all kind of blending into each other. So many of you are wearing colors, multiple colors on your clothes. And so our experience of a color is going to be influenced by the presence of other colors. So for example, looking right here on my shirt, because this yellow is right next to this patch of blue, it's going to make that blue look a lot warmer than it would be in isolation. And this is what is known as color contrast. So the color of one region is going to induce the opponent color in a neighboring region. So what you're looking at here is a bar of olive green, and it's kind of hard to appreciate it on the screen right here, but from the computer, this actually looks more green against this red. And this actually looks like a warmer green, almost brown against this green. Fun color tricks. I will show you one at the end of class with some really cool spirals. And I'll start class on Friday with a T-Rex that doesn't stop staring at you. Yeah. Yeah, you know the one. Don't spoil it for anybody. All right, does anybody need some more time? Everybody good? Yeah, no, that's totally fine, Mariah. Thanks for speaking up. Okay, everybody good? Okay, so here's an example of how color contrast can really mess with us. So how many of you have seen this before? Okay, so A and B look different, right? They're not. So if we actually take a color finder, so if you go into Microsoft Paint, they're actually the same shade. Now, here's why you might mess that up. So here we've got this cylinder that's casting a shadow, right? So the idea is that if that shadow weren't there, that object would be lighter. So here's what's happening when these are the same shade. We assume that this one is darker because of the shadow that is getting cast. So we process this as if that shadow were not there. If we discount that extra darkness because of the shadow, this is what we perceive, despite the fact that they are actually the same color. Okay. So colors can also bleed into each other. So this is what is called color assimilation. So this is what you're kind of seeing here at the bottom. Neighboring colors will take on the chromatic quality of each other. So right here, I've got blue squares intercut with red. And that makes a warmer shade of red and it actually makes the blue squares kind of warmer looking. Here, the blue is intercut with green and it kind of has a cooler looking quality to it. Here's yellow. Here's what it looks like when it's intercut with red. Here's what it looks like when it's intercut with green. Likewise, here's red when it's mixed with yellow. Here's red when it's mixed with blue. Here's green when it's mixed with yellow. Here's green when it's mixed with blue. So your experience of a color is going to be influenced by the colors that surround it. Everybody good? Okay. So here's kind of an example. If that's too bright for you, look away. What you are looking at here are spirals. Now, here is my question to you. Do those colors look different to you? Does anybody see blue and green spirals? What if I told you that they're based on the exact same color? Some of you don't believe me. You know what will help you a little bit? One of the easiest things that you can do is kind of get up to the side. So here's what's happening. The ones that look green are intercut with orange, giving them a warmer looking quality. The ones that look blue are intercut with pink or purple to kind of give it a cooler quality. But those spirals, in fact, are the same blue-green shade. We've just used the principles of color assimilation to make them look different than they actually are. And now I'll turn it away because some of you look like you're getting a headache. Okay. Now, sometimes things like color assimilation and color constancy. Okay. So I was teaching biopsych for like my second time when this happened. Like I went to go to Dairy Queen with my partner and then we came back and I had all of these emails about the dress. By the time that I got to biopsych the next day, half of the class was like, please explain the dress. And the other half was like, no, Dr. Gilchrist, don't explain the dress. We're sick of it already. It's like the corn thing. I'm already sick of the corn thing. It's got the juice. Okay. So, okay, here's my question to you. How many of you see that dress as white and gold? How many of you see that dress as black and blue? How many of you see something kind of in the middle? It is actually black and blue. Now, what's kind of wild is that I'm looking at it over here and it looks white and gold. I look over there, it looks more black and blue. So what was really interesting is that when this first came out, there were posts that were like, if you saw white and gold, you have problems with your eyes. You don't have problems with your eyes. You are fine. Your experience of a color. So here's the thing. We like to imagine that our experience of colors is like this. It's white, it's white, it's white, it's blue, for example. But it's not that simple. It's not a sharp cutoff. It's a continuum like this. And here's what's really interesting. We all have different boundaries for where we define those categories of colors. Now, here's when I realized that something really interesting was going on. I was down in Hink House basement looking at the dress on my phone. It was white and gold. I walked outside suddenly in the sunlight and it was suddenly black and blue. And I can change it depending on the lighting conditions outside the monitor I'm looking at. And there's also the implication that people that look at screens more, which emit blue light versus being out in the sun, which is yellow light, can also change your experience of the dress. Additionally, there are a lot of different ambiguous signals coming. We don't know if this was photographed with a flash. We don't know where the lighting source comes from. So we're all defining those categories in different ways. So this was fascinating because this is one of the first times that everybody looked at the exact same thing, and half of the people saw one thing and half of the people saw something different. Okay, so I'm going to go ahead and stop here. I will talk about depth perception, and I think we will be finished up. So we will move on to visual perception part 2 when I get back. So on Friday, we'll finish this up. So I may record a little bit longer just to make sure we get through face expertise. So it may be closer to 30 or 40 minutes, but feel free to break it up in parts. Since it's going to be posted tonight, you can watch it over multiple days and break it up into smaller sections, but you'll be okay. I just want to make sure we have enough time before the exam on Monday. Sound good? All right. Thank you so much for being here, and I will see you on Friday.